In this video, we're given that the sine of x is equal to negative 1/3 and that x is greater than pi but less than 3 pi over 2. This tells me that the angle terminates in quadrant 3. And we want to find the exact value of cosine of x, tangent of x, sine of 2x, cosine of 2x, and sine of x over 2. So we're going to use some basic trigonometry along with some identities. Looks like we'll use a double angle identity, half angle. Start off with the fact that we're given the sine of the angle. So this is really, I can define this really as y over r. So I'm going to use the fact that if I find a point on the terminal side of the angle, I can use that point to generate the trig function values of that angle. So I'm going to ignore the sign for right now and just call this a 1, this a 3 here. So this would be y over 3, where y is the second component of a point on the terminal side. So the right triangle, so let's assume that this is a right angle here. This would be opposite, and the 3 would be the hypotenuse here, and then this would be the square root of 8. Square this, square this, square this. That justifies that would be a right triangle. And then I can simplify this, square root of 8 as 2, square root of 2. So with this information then, I can say, well, okay, assuming this n is the reference angle of that particular angle, and again, this is going to be lying in quadrant 3, like that. Then the cosine would be the adjacent over the hypotenuse, so this would be 2 square root of 2 over 3. And in quadrant 3, the cosine of the angle would be negative. So this would be cosine of x then for that particular angle would be negative 2 times the square root of 2 over 3. Now for the tangent, again, I can just use the triangle here. That'd be 1 over 2, square root of 2. Rationalize that by multiplying by the square root of 2. That would give me the square root of 2. Square root of 2 times square root of 2 is 2, and then times 2, that would be 4. And in quadrant 3, if an angle terminates in quadrant 3, which this one does, then the tangent would be positive because the x and the y would both be negative, the x component and the y component. So that would give me a positive square root of 2 over 4. Now for this one here, I have the sine of 2x, and of course I'm dealing with just x. So here I'm going to use a double angle identity here. We know that the sine of 2 times an angle is 2 times the sine of the angle, x. You take half of that, and cosine of half that angle. Now I got the function here in terms of x instead of 2x. So now I can just use information I've already derived here. We know the sine of x is negative 1/3, and we just found the cosine of x in part 1. So this would be negative 2 square root of 2 over 3. And then we just simplify this. Negative times negative will give me a positive. So we have here a 2, and times a 2, that'll give us a 4 square root of 2, and 3 times 2 will be 9. And that's the answer to number, or letter C, part C. So we got minus 2 square root of 2 over 3 for the cosine in part A. For part B for the tangent, square root of 2 over 4. And for part C, 4 times the square root of 2 over 9. Now for D, again in the same way as part C, we have cosine of 2x. We're dealing with just the angle x. So let's break this down. And we have several identities we can use for this one here. But one of them is that the cosine of 2x can be written as 1 minus 2 sine squared of half that angle. That would just give me x. Now I can work with that. This is 1 minus 2. And we're given the sine of x to be negative 1/3. So I can just plug that in. And then that's going to be squared. So that's equal then to 1 minus 2. Negative 1, or negative 1/3 squared is 1/9. It's equal to 1 minus 2/9. and 1 is 9 over 9. Get the same denominator, so this will give me 7 over 9. So that's the solution to part D. I'm going to clear this to get some more room here. So for this one, we have the sine of x over 2. So this would be your half angle formula that I'd have to use for this one. So the half angle formula for the sine of x over 2, there's also one for, of course, cosine, is plus or minus the square root of 1 minus cosine of twice that angle. So this will give me an x here, and this is over 2. Now, notice I have a plus or minus here. So what's going to determine that is where the angle is. So remember here, I'm computing the sine of x over 2. So I know what quadrant the x is, but where is x over 2? So let's just do this. Let's just divide this by 2. Give me this. Divide this by 2. We're taking 1/2 of that. And this then would be 1/4 here. So you can see then that x over 2 is greater than pi over 2, but less than 3 pi over 4. That's going to put this angle in quadrant 2. In quadrant 2, the sine of an angle is positive. So I just make it a positive here. And then I just substitute. I got 1, of course, is given by the formula, and then the cosine of x, we found that over here in part A. So this would be minus 2 square root of 2 over 3. And this is over 2. So let's just clear the fractions inside the radical here. Let's multiply this by 3. This is a 3 here, and multiply this by 3. So the 3's cancel here, here. You multiply over here, so this will be 3 plus 2 square root of 2. Then 3 times 2 in the denominator is a 6. So I get positive the square root of the right hand is 3 plus 2 square root of 2 over 6. Now I could rationalize this by multiplying the denominator and numerator by 6, but we'll leave it in this form there. Thanks for watching. We'll see you next time.